Okay, this is 7.1, Ratios and Proportions. When we finish, we're going to be able to write ratios and solve proportions. So before we get started, it's essential for you to understand that you can write a ratio to compare two quantities. So as we go through this, I want you to think that you're comparing two quantities. So first of all, what is a ratio? So a ratio is a comparison of two quantities by division. You've got your two numbers. In this case, we're going to be talking about A and B, where B is not equal to B is not equal to 0. So one of the ways that we're going to look at this, so you could write it as A over B. That would be a ratio. You could also write it as A colon B, or you could write it as A to B. So a couple of things that you want to keep in mind. Whenever you write a ratio, it needs to be in the same unit, and you want your ratio in simplest form. So that means you would reduce it like you would any other fraction. Okay, so let's get started. Let's look at number 1. So the bonsai bald cypress tree is a small version of a full-size tree. A Florida bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? Okay, so it's telling us the order that it wants to compare these. So it's going to compare the bonsai to the Senator. So what is the height of the bonsai? Oh, so they give us a picture right over here. So the bonsai is 15 inches. Now, what is the height of the Senator? The Senator is 118 feet. Okay, so if I go look at what I need to make sure I have the same, are my units the same? Nope. I'm going to have to change that. So I need to change 118 feet to inches. So you're going to look how many inches are in a foot. 12 inches are in a foot. So I'm going to do 15 inches. 118 times 12 is 1,416 inches. So now we need to simplify our fraction. So what do you think we're going to do? So what's 15 divisible by? 1, 3, and 5, right? So is the denominator divisible by 5? No, so let's divide everything by 3. So So 15 divided by 3 is 5. 1,416 divided by 3 is 472. So my ratio of the height of the bonsai to the height of the Senator is 5 to 472. So you can leave it in fraction form, or you can write it as 5 to 472, like this. Okay, so let's take a look at our second problem. Dividing a quantity into a given ratio. Okay, so members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraisers. They plan to buy 120 pots of flowers. The ratio of number of tulip pots to the number of daffodil pots will be 2 to 3. How many pots of each type of flower should they buy? So my tulips plus my daffodils are going to equal what? 120. So which number goes with tulips? 2, right? So I'm going to let 2x equal my tulips and 3x equal my daffodils. So now I can say 2x plus 3x is equal to 120. I'm going to combine my like terms. So I get 5x is equal to 120. Get x by itself, I'm going to divide by 5. So x is equal to 24. Am I finished? No, I've just found x. So to find the number of tulips, I'm going to plug 24 into x. So what's 2 times 24? It's 48. And what is 3 times 24? That's going to give me 72. So I need 48 tulips and 72 daffodils. Okay, now I want you to do this one on your own. Go ahead and hit pause. And then when you're finished, hit resume. Okay, now this one, it wanted you to find the measures of 2 supplementary angles, and the ratio was 1 to 4. What's the measure of supplementary angles? That's right, it's 180 degrees. So I'm going to do this one just like I did the tulip problem. 1x plus 4x equals 180. So then I have 5x equals 180. Divide both sides by 5. So x is equal to 36. So the first angle is equal to 36. And 4 times 36 is equal to 144. So 1x would be my smaller angle, and 4x would be my larger angle. Okay, now we're going to talk about extended ratios. So an extended ratios compares 3 or even more numbers. So in the extended ratio A to B to C, the ratio of the first 2 numbers is A to B, the ratio of the last 2 numbers is B to C, and the ratio of the first and last numbers are A to C. Okay, let's take a look at problem 3. The lengths of the sides of the triangles are extended in the extended ratio 3 to 5 to 6. The perimeter of the triangle is 98 inches. What is the length of the longest side? Now, when we just look at these numbers, which side do you think is going to be longer? That's right, 6. How do I know it's longer? Well, it has the biggest number. So I always find it helpful to sketch out a little triangle, and it doesn't matter where I put the numbers, as long as I am aware of which one is the biggest side, is the longest side. So I may put it, this is 3x, this is 5x, and this is 6x. So your sketch doesn't matter. So I'm going to erase these, and I'm going to try to put it, close to where I think it is. So my shortest side would be here. So I'm going to call that 3x plus 5x plus 6x. And what is that going to equal? All of that's going to equal 98, right? So 3x plus 5x plus 6x equals 98. And when I combine my like terms, 3 plus 5 is 8, plus 6 is 14. So now I have 14x is equal to 98. I'm going to divide by 14. So x is equal to 7. So what is the length of my longest side? Well, 6 times 7 is equal to 42. So 42 is my longest side. Actually, 42 inches is what I should put. Okay, so now there's one for you to do. I'm going to get you to pause it, and when you unpause it, I'm going to have the worked out solution, okay? I'm not going to work it out this time. It's just going to have the answer. Okay, so x was equal to 3. You said 4x plus 7x plus 9x is equal to 60. Combined your like terms, solved for x. You got x was equal to 3. Now you have your 3, and you're going to plug it into 4x. 4 times 3 is 12. 7x, 7 times 3 is 21. And 9x, 9 times 3 is 27. Okay, so it's super important that you understand if two ratios are equivalent, we can write an equation stating that the ratios are equal. And if we have a variable, we can solve to find the variable. So let's take a look at problem 4. I want to know what is the solution of each proportion. So what I'm going to do is I am going to cross multiply. So I'm going to get 6 times 4 is what? It's 24. I'm going to say that is equal to, what's 5 times x? It's equal to 5x. So now I'm going to divide both sides by 5. So I know that x is equal to 24 over 5, or 4.8. Now let's take a look at problem B. So the same thing, I'm going to cross multiply. So now I have 3 times y plus 4 is equal to 9y. So now I need to distribute. So I have 3y plus 12 is equal to 9y. I'm going to subtract 3y from both sides. So I get 12 is equal to 6y. I'm going to divide both sides by 6. So y is equal to 2. Now let's take a look at some of the properties of proportions. So for right now, they're not that important, but on the sections that we have coming up, you're going to notice that we use these every once in a while. And we may set things up different, but if you know these properties, you can see that we really set them up the same way. So A to B is equal to C to D is equivalent to B to A is equal to D to C. So all we did was take the reciprocal of both equations, of both ratios. So now we have AB is equal to CD. And what did we do? Oh, we put B, we just kind of flipped them on their sides. So we said A to C is equal to B to D. And this last one, numerator plus denominator divided by denominator. numerator plus denominator divided by denominator. Those are equivalent. Okay, now let's take a look at problem 5. We need to write equivalent proportions. So it says that x to 6 is equal to y to 7. And it wants us to write the proportion in terms of x and y. Well, if I go back to my little chart over here, I think I can use the second property. And remember the second property, I took the numerators and turned them into a fraction. And I took the denominators and did those into a fraction. So let's see. Oh, I can do the same thing. So I can say x to y is equal to 6 to 7. Now let's take a look at the second method, and that's all I need to do. So I've got x over 6 is equal to y over 7. Okay, now I'm going to cross multiply. So I get 7x is equal to 6y. So I have x right here. So I'm trying to make it look like this. I want it to be x over y. So I can divide this side by y. Now who's in the way of x being by itself? Okay, 7. How's it attached? Multiplication. What's the opposite of multiplying? Dividing. So I can divide this by 7. That's going to cancel out. What I do to one side, I have to do to the other. Oh, and good things have happened for me. I have x over y is equal to 6 over 7.